Okay, today what we would like to do is we'd like to look at general equations for sine and cosine functions, but we would like to include what is referred to as horizontal and vertical shifts. So for example, the past few days, we've always looked at this. Y equals A times the sine of B times X. Or Y equals A times the cosine of B times X. That's what we've looked at the past 2 days. Today, we want to add in C and D. I know it sounds bad, but it's not too bad, okay? The rule stays the same. The amplitude is still the absolute value of A. That does not change. Second of all, the period is still 2 pi divided by B, and B is the number in front of the X. If things are on the outside of the function rule, they affect it vertically. If things are on the inside of the function rule, they affect it horizontally. So, which one do you think is vertical, C or D? Which one's on the outside? D's on the outside. It's after we take the sign of it. So D's on the outside. So the vertical shift will just be D. That's easy, huh? The one that's just a little almost easy. The one that's a little bit confusing, I guess, might be the horizontal shift. And what we do is we set bx minus c equal to 0 and solve for x. There's a number of ways to teach this. I've taught it for many years, and I've kind of settled on that. I think that that's the best way for people to understand what the horizontal shift is. Remember yesterday when we sketched the first graph and you're scratching your head, but by the time we did the fourth one, you're like, yeah, I got this? Do the same way today. You'll be good to go. So flip it over, and it says, always apply the transformations in this order, okay? And I'm going to start by doing letter B. I'll do letter A after we do letter B, okay? We don't start by actually look at the amplitude and period. We actually start with the vertical shift. If you look at the other sheet of notes that I gave to you, you can see that it says it right here. Amplitude, period, horizontal shift, and vertical shift. You might want to write on there 1, 2, 3, 4. That's the order that I do the shifts and the transformations. I start with vertical shift, and then I go back to the top. Okay. We start with a vertical shift, and it's not that bad. What we do is we mark out D units and a horizontal axis through it. So, for example, and this is crucial that you get this piece right here. At. Suppose we didn't have this plus 2 on the end. What would be the biggest value that this function would reach? 3. What would be the lowest value? But if we add 2, instead of going up to 3 and down to negative 3, what would be the highest? And what would be the lowest? Negative 1. Because everything shifted up 2 units. Do you see that? We take this region and we shift it up to there. We move everything up 2. Do you see that? So here's what we do. We identify the vertical shift. Vertical shift is what? 2. It's that number on the end. And I'm going to draw a horizontal axis right through that. Because instead of it going up and down right across the x-axis, it's going to, right here, just 2. It's going to go up and down about this axis. Now, what is the amplitude? The amplitude is 3. So, once we identify the amplitude, we mark the max and min. You guys just did a great job of telling me that if the amplitude is 3 and the vertical shift is 2, what is going to be the highest spot that the graph will reach? 5. It will be 3 units up, which is 3, 4, 5. And it will be 3 units down, which will be. Is everybody convinced by that it will go to a height of 5 and it will go down to 1, -1? Okay. Did you say something? Did you say you're confused? Oh, you've been convinced. Thank you. Okay, the period, 2 pi over b, and divide into 4 parts. What's the number in front of x? 1. So what's the period going to be? 2 pi. So I'm going to mark 2 pi. Hi. I'm going to divide it into 4 spots. Let's divide it in half, and what do we get? Divide in half again. Pi over 2. Now let's count. 1 pi over 2, 2 pi over 2, 3 pi over 2. Good. Horizontal shift. There is no horizontal shift because you take what's on the inside, and here what's on the inside is just x. You take that and set that equal to 0 and solve. So there's 0 horizontal shift. The horizontal shift is 0. There's nothing there. Do you see that over on letter A, there is a horizontal shift? But here there's not. Okay? So we'll get to the horizontal shift later. Now, it's not too bad. Does cosine start at the max or min, or does it start in the middle? Starts at the max or min. Cosine starts at the max or min. So since it's a positive 3, will it start at the maximum or the minimum? Maximum. So it starts all the way up here at 5. And then instead of crossing over that x-axis, it's just going to cross over this horizontal axis that we drew for the vertical shift. So at its first spot right here at pi over 2, you're right there. What's going to be its height at pi? It's going to go all the way down to -1. And that's the lowest it goes. And then after that, it will go back up. And after that, these are old graphs, you guys. I'm changing the way I do it to where I want you to show 2 full periods on both sides. I can't show 2 full periods here because I didn't give myself enough room. But I am going to do a half of one on that other side. Okay. So if I go backwards, what's going to be the height at -pi over 2? Yep, it'll be at a height of 2. And then what's going to be the height at -pi? -1. And so that's enough information to really sketch a nice looking graph here. Does anybody have really nice looking sine graphs that they could display so we can see? Be really proud of you, or you're really proud of yours? Let's see what you got. Okay, what do you guys think? Rated on a scale of 1 to 10, what do you think? Oh, wow. No, that's pretty harsh. A 1. Come on, folks. Well, it continues to go up at the end. It should kind of come back down, but I think you did pretty good. Here you go, Phil. Anybody else have a... Oh, hey, Mitzi's got a pretty good one here. Look at this one. 9.5, I give it an 8. All right. Uh-oh. Nadia, look at that. I give this a 9.2 right here. That's pretty good, huh? Okay. Does anybody have a really horrible wave? Okay. All right. If here's the quality of a horrible one. Please try to refrain from doing this, folks. You know, you draw more corners than you do curves. I don't do that. All right. So that's one example. Do you think we could do this? All right, let's do another. Let's go back to A. What's the vertical shift? What's the D value on the outside here? 0. There's no vertical shift. So therefore, it's centered right along the x-axis. Hi there. Yeah. Okay. So this is centered at 0. What's the amplitude? 1. So if the vertical shift is 0, there's no vertical shift, and the amplitude is 1, what's my highest value? 1. What's my lowest value? Good. Well, see, and when I look at that, those don't look like they're evenly spaced. So I go back and I redo it. I want it to look like a really good graph. Okay, we have time. All right, so now the period. The period, what's the period? 2 pi divided by b. What's the b value? The b value is the number in front of x. What's the number in front of x? 1. So the period is 2 pi. I divide that up into 4 parts. And this is going to be the same as our last one. These are bad graphs. I didn't redo them from last year, so sorry about that. Okay, here we go. Now it says that what's the horizontal shift? In order to find the horizontal shift, we take the inside and set it equal to 0 and solve. So if I take the inside and set it equal to 0 and solve, how do you solve for x? What do you do to both sides? Add pi over 4. X is pi over 4. So that's the horizontal shift. We don't apply the horizontal shift. First, what we do is sketch a ghost graph. Then make the shift. A lot of people struggle with the horizontal shift. So we're going to sketch a ghost graph first, and then we're going to make the shift. And I'll show you what a ghost graph is. Let's pretend like we didn't have a horizontal shift. Right now, let's just sketch the stuff that we have in green here. It's sine, so let's start the max, min, or the middle. Will it start by going up or going down? It will go up. Instead of making a solid line, I'm just going to make a light dashed line. You see that? I just make a dotted or dashed line. And now I will make the horizontal shift. pi over 4 is how much of a tick mark? It's half of a tick mark. Because half of pi over 2 is pi over 4. So I'm going to move all of these points half of a tick mark to the right. I'm shifting everything horizontally. So the red graph I call my ghost graph, and the blue graph is the actual graph. Can you see how the blue graph is the same as the red graph, just shifted horizontally pi over 4 units? Isn't that pretty? See, I can actually take this blue graph here, and look, I just drag it right over the other one. See that? Isn't that cool? That's impressive, is what I say. All right, we're going to try D. We're going to move on from C over to D. What's the vertical shift? 3. So what I do is I mark off 3. 1, 2, 3. What's the amplitude? 1. The amplitude is the absolute value in front of sine. So absolute value -1 is +1. So this is my vertical shift through 3. If the amplitude is 1, what is my maximum value? I'm at 3, and if my amplitude is 1, then I'm going to go all the way up to 4. And I'm going to go all the way down to 2. 1 unit up and 1 unit down, right? A 2. So you're going up to 4 and down to 2. Yep. What's the period? I take 2 pi and divide it by what? 2 pi and divide by 2 to get pi. I mark out pi and divide it into how many parts? 4. What's half of pi over 2? Pi over 4. Now I'm going to count 1 pi over 4, 2 pi over 4, 3 pi over 4. I'm going to go backwards as well. That's what I do. All right. True or false? There is not a horizontal shift. False. There is a horizontal shift, isn't there? But before I do the horizontal shift, I should sketch a ghost graph. So I'm going to sketch the ghost graph, and then we'll do the horizontal shift. This is sine, and it starts by going up or down. And is it going to start at the max, min, or middle? Middle. So I start here, and as Cass said, it starts by going down. Well, hi, buddy. Sure. So I sketched the ghost graph. Now I have to apply the horizontal shift. How do I calculate the horizontal shift? I take the inside And I set it equal to what? 0. So 2x minus pi over 2, and I set that equal to 0. How do I solve that? What do I do to both sides? Add pi over 2. So I have 2x is equal to pi over 2. I can divide by 2 or multiply by 1/2, right? Because if I multiply both sides by a half, what's half of 2x? And what's half of pi over 2? Pi over 4. So our horizontal shift is pi over 4. So I'm going to move every single one pi over 4 units. How much of a tick mark is pi over 4? 1 tick mark. So I'm going to move everything 1 tick mark. It I said that this is probably the most challenging part of this unit. I think that when you graph sine and cosine yesterday, everything was great, but now we should throw in 2 more transformations, and it gets a little bit more confusing. But we're gonna practice this Thursday and Friday. Yes. Yes. Question. Okay. Let's focus, kids. This is a really good question. The ghost graph started at the middle. After it shifted, it went to the max. And so it looks like cosine, right? It turns out, Eric, that every single graph that we write as cosine, you could apply a horizontal shift and make it look like sine. And every graph that looks like sine, apply a horizontal shift and make it look like cosine. So, because this graph up here in blue, if I grab it, whoop, if I grab that graph in blue, I can turn it from a sine graph right into a cosine graph by doing a horizontal shift. See that? Okay, you guys are ready? You have a very, very short assignment tonight. Tomorrow, we will do a worksheet on this in class. Shh. Boys and girls, I'm only giving you 4 problems to practice. I know that these aren't necessarily easy, but tomorrow we're going to do 2 more examples like this in class, and then you're going to have a worksheet on it. Okay? And this is the last content that you would have to be able to master for your first quarter final exam. So let's focus. Awesome. Because the juniors will need help getting caught up tomorrow because they're gone. So